All right, everyone, we're back here talking about skew um, in the descriptive statistics presentation. So I'm on slide 12. Skew is an asymmetrical distribution when you go to graph your data. So we assume that data are normally distributed, which is the theoretically the most frequently occurring type of distribution in nature. If I went out into the preserve and captured 20 squirrels out there and measured them all from the tip of their nose to the tip of their tail, and then put all of their lengths in a graph, I would expect that graph to be normally distributed. There'd be an average at the peak of the graph in the middle, and as values of the lengths of the squirrels became greater or smaller, the frequency with which those are seen would get lower and lower. So we assume data are normally distributed, and that's called a normal curve or a normal distribution. Sometimes it's called bell shaped. But skew is when you have an asymmetrical distribution. So the normal distribution is symmetrical. If you cut it right down the middle, you would have two equal pieces, mirror images of one another. An asymmetrical distribution is one that's lopsided or skewed. So you can have skew that's either positive, skewed to the right, or negative, skewed to the left. And I'll show you on a subsequent slide. It has that information on there, what it looks like. So I'm on slide 13 here with conversation on kurtosis. So hopefully skew is something that you heard about in statistics. If you didn't, that's okay. We're talking about kurtosis here now, which probably is something new to you. But kurtosis refers to the peakedness or flatness of a distribution. So you remember on any graph of data, the y-axis indicates the frequency of occurrences of that score value. So if you have a very peaked curve, it's called a leptokurtic distribution, and it's also positive kurtosis. And what that means is there's less variance in the data. More of the data are stacking up on a fixed amount of particular values that are all clustered closely together. A negative kurtosis or a platykurtic distribution has a flattened peak. So it's like if you stepped on that leptokurtic peak and just flattened it down. That's what a platykurtic curve looks like, and that's negative kurtosis. What that means is there's a great amount of variability in the data set, so there's a lot of spread in the data, and the most frequently occurring value is barely the most frequently occurring because there's good numbers of all a wide range of data that are in the data set. So that's kurtosis. Uh, from a statistical diagnostic, which we don't have to discuss, but if you wanted to do this statistically to determine how much kurtosis you had, a kurtosis of zero value would indicate normal, and as it got higher, that would indicate greater kurtosis. On slide 14 with skew, you can see here that skew represents an uneven distribution, an asymmetrical distribution. And you can see that a skewed positive distribution is one that we would also say it's skewed to the right. And what that means is there's some outliers that are very high in the data set, a couple of them, maybe one even, that are pulling the mean up and pulling the right side of the tail of the distribution up. Whereas if you have a negative skew, um, you have skew to the left, which is basically very low value score that is pulling the mean down and pulling the left side of the tail of the distribution down along with it. So you have positive skew, and then you can have negative skew. Same thing with the diagnostics with the zero equals normal. In the next clip, I will talk a little bit about variability.